and good morning everyone. Today I am going to discuss to you of how I have obtained the derivative of each of the given function. So the first function given f of x equals 3x squared plus 5x minus 2. So all we just need to do is to get the derivative of each of the terms. So the derivative of 3x squared by application of the power rule, that would be 6x, and 5x, that would be 5, and then the derivative of 2, that would be 0 by application of the constant rule. Therefore, our answer for the derivative of the given function is 6x plus 5. Moving on to number 2, we are given g of x equals negative 4x to the fourth plus 5x to the third minus 2x plus 3. Same application from number 1, therefore we have obtained negative 16x to the third plus 15x squared minus 2 as our derivative. So as we have noticed, we no longer see the 3. It's because the derivative of 3 as constant is 0. So moving on to number 3, we are given the function f of x equals 2 times square root of x plus 7 square root of x cubed minus 2 all over x squared. So the very first thing that we need to do is to rewrite this function by transforming from radical to rational. So that would become 2x to the power of 1 half plus 7x to the power of 3 halves minus 2x to the power of negative 2. So applying the power rule, 1 half times 2, that would be 1x, or x, and then 1 half minus 1, that would be negative 1 half, plus 21 halves x to the power of 1 half. This is because 3 halves, looking on the second term, 3 halves times 7, that would be 21 over 2, and then 3 halves minus 1, that would be 1 half. So we have obtained 21 halves x to the power of 1 half. And then for the third term, we have there as negative 2 multiplied to negative 2, that would be positive 4, and then negative 2 minus 1, that would be negative 3. So we can also express this into its radical form. Therefore, our answer for the derivative of the third function is f prime of x equals 1 all over the square root of x plus 21 halves square root of x plus 4 all over x to the third. Moving on to number 4, g of x equals 8 square root of x to the fifth minus 7 x to the fourth plus 5 all over square root of x. So we can rewrite this into its radical form, especially with those with radical signs. That would be 8x to the power of 5 halves minus 7x to the fourth plus 5x to the power of negative 1 half. So same application from number 3, we have obtained 20x 3 halves. Since we have multiplied 5 halves times 8, that would be 20, and then 5 halves minus 1, that would be 3 halves. Same application for the second term, that turns into negative 28x cubed minus 5 halves x negative 3 all over 2. So now simplifying, we have obtained 20 square root of x cubed minus 28x cubed minus 5 all over 2 times x cubed. That would be our answer. Now for number 5, we are given the function f of x equals x squared plus 7x minus 18 all over x plus 9. So before we proceed, I have noticed that the numerator can be factored, and the factor of it is x plus 9 times x minus 2, or the quantity of x plus 9 times the quantity of x minus 2. Then copy the denominator. And since we can see that there is a quantity that can be cancelled, which is x plus 9 from numerator and denominator. Therefore, the remaining value is x minus 2. And to derive x minus 2, that would be 1. Since the derivative of x is 1, and then the derivative of 2, or any constant, is 0. Therefore, our answer for number 5 is 1. Moving on, number 6. This is same application from number 5. we are given 5 f of x equals x squared minus 5x minus 24 all over x minus 8. So we can factor the numerator, which is x, the quantity of x minus 8 times the quantity of x plus 3 all over x minus 8. So we can cancel the quantities x minus 8 and x minus 8 from both numerator and denominator. So the remaining term is x plus 3. Now to derive x plus 3, that gives us 1. Number 7, we are given f of x equals x to the power of negative 3 plus 7 square root of x cubed minus 4x squared all over 2 square root of x. So this will be an application of, we can use the quotient rule for this. And with that, we are going to get the v and the derivative of the u. Our v is 2x 1 to the power of 1 half, and then our u is negative 3x to the power of negative 4 plus 21 over 2x to the power of 1 half minus 8x. And then now for the second term, our u is x to the power of negative 3 plus 7x 3 halves minus 4x squared times the derivative of our v, dv is x to the power of negative 1 half. Now, for our v squared, that is 2 square root of x to the power of 2. To simplify, we have obtained negative 6x, negative 7 to the negative 6x to the power of negative 7 halves plus 21x minus 16x to the power of 3 halves minus the quantity of x to the power of negative 7 halves plus 7x minus 4x to the power of 3 halves all over 4x. Since 2 square root of x squared, that gives us 4x. Now to simplify our numerator, it gives us negative 7x to the power of negative 7 halves plus 14x minus 12x to the power of 3 halves all over 4x. And we can also simplify this term by term by dividing each term by 4x, and that gives us negative 7 all over 4x 9 all over 4x to the power of 9 halves plus 7 halves minus 3 square root of x. So that is how we have obtained the derivative of the function x to the power of negative 3 plus 7 square root of x cubed minus 4x squared all over 2 square root of x by applying the quotient rule for differentiation. Now moving on to number 8. We are given h of x equals 2 all over x cubed plus 5x squared minus 8 times square root of x to the 7th all over negative 3 square root of x. So this is going to be an application of the quotient rule. So by applying the quotient rule, we have obtained negative 3x to the power of 1 half as our v times negative 6x to the power of negative 4 plus 10x minus 28x to the power of 5 halves minus 2 all over x cubed plus 5x squared minus 8x to the power of 7 halves times negative 3 halves x to the power of negative 1 half all over negative 3 1 all over x squared because our v is negative 3 square root of x. And to set it to square, it gives us 9x. And for our numerator, by applying operation, now it turns into 18x to the power of negative 7 halves minus 30x 3 halves plus 84x cubed minus the quantity of negative 3x to the power of negative 7 halves minus 15 halves x to the power of 3 halves plus 12x cubed. Now to apply addition and subtraction, it gives us the answer 21x to the power of negative 7 halves minus 45 halves x to the power of 3 halves plus 72x cubed all over 9x. To simplify term by term, we have obtained 7 all over 3x 9 halves minus 5 halves square root of x plus 8x squared. So this simplification is obtained through dividing each term by the denominator. So we have obtained it through dividing 21x negative 7 halves divided by 9x, and then for the second term, 55 over 2x to the power of 3 halves divided by 9, and 72x cubed divided by 9. So therefore, we have obtained our answer, which is h prime of x equals 7 all over 3x 9 halves minus 5 halves square root of x plus 8x squared. Now moving on to number 9. S of x is equal to 2x to the power of negative 3 sec x. So this is an application of the product rule. Thus, it gives us 6 prime of x equals negative 6x minus 4 times 6x plus 2x to the power of negative 3 sec x tan x. Now, to simplify, it gives us the answer, negative 6 sec x all over x to the fourth plus 2 sec x tan x all over x cubed. For number 10, we are given the function f of x equals 3x to the fourth ex. Therefore, the derivative of this one is 12x to the third e to the x plus 3x to the fourth ex by simply applying the rule. Or we can also get the factor of these terms, which is e to the x. And therefore, we have obtained e to the x times 12x to the third plus 3x fourth. And that would be our answer for number 10. Now for number 11, we are given the function f of x equals negative 7x to the third e to the x. And applying the same rule from number 10, it gives us negative 21x to the second ex minus 7x to the third e to the x. Therefore, by getting the factor, which is negative 7x squared e to the x, we have obtained the derivative or its differentiation, which is negative 7x to the second ex times 3 plus x. For number 12, we are given the function f of x equals 5x squared cos x. So now, by getting its derivative through product rule, we have obtained 10x cos x minus 5x squared sin x. Number 13, h of x equals 2e to the x square root of x. Now, to differentiate this function, we have obtained 2e to the x square root of x plus 2e to the x times 1 all over 2 square root of x. Now, to simplify this one, we have obtained 2e to the x square root of x plus e to the x all over square root of x. Number 14, we are given the function f of x equals 4x to the fourth minus 5x to the third plus 2x squared e to the x. So, f prime of x, to get the derivative of 4x4, that would be 16x cubed, and the derivative of 5x to the third, that would be negative 15x squared, and then the derivative of 2x squared ex is 4x e to the x plus 2x squared ex. Now, to combine them all together, it gives us the answer, f prime of x equals 16x to the third minus 15x squared plus e to the x times the quantity of 4x plus 2x squared. Now, for number 15, we are given f of x equals tan x all over 2x squared plus 1. And this gives us the hint that the rule that we are going to use is the quotient rule. So, applying the formula, it gives us f prime of x equals 2x squared plus 1 sec squared x minus tan x 4x all over 2x squared plus 1 squared, since our u is tan x and our v is 2x squared plus 1. Moving on to number 16, g of x equals sin x all over ex plus 5. Now, g prime of x equals, our u is sin x and our v is e to the x plus 5. Our u is e to the x plus 5. I know, our numerator would be e to the x plus 5 cos x minus e to the x sin x all over ex plus 5 squared. And that simply gives us our answer by applying the quotient rule. Number 17. We are given the function f of x equals x squared minus 3x plus 2 all over x plus 3. So the same thing that we are going to apply, which is quotient rule, and it gives us our numerator as x plus 3 times the quantity of 2x minus 3 minus x squared minus 3x plus 2 times 1 all over x plus 3 squared. So applying operations, it gives us 2x squared plus 3x minus 9 minus the quantity of x squared minus 3x plus 2 all over x plus 3 squared. So compressing them together by applying our operation, now it gives us 2x squared minus x squared, that would be x squared, and then 3x plus 3x, that would be 6x, and then negative 9 minus 2, that would be negative 11, and then we are just going to copy our v, and hence it gives us x squared plus 6x minus 11 all over x plus 3 squared. For number 18, we are given f of x equals 2e to the x all over x minus 2ex. Now to simplify this term, we now obtain f of x equals 2e to the x times x minus 2e to the x minus 2e to the x times the quantity of 1 minus 2e to the x all over x minus 2ex to the power of 2. Now to simplify this, we have obtained 2x e to the x minus 4e to the power of 2x minus 2e to the x plus 4e to the power of 2x all over x minus 2e square root of all over x minus 2e to the x squared. Now by simplifying it further, our answer would be 2e to the x times the quantity of x minus 1 all over x minus 2e to the x to the power of 2. This is simply because negative 4e to the 2x plus 4e to the 2x is 0, and then we have just factored out 2x e to the x and negative 2e to the x, and that gives us 2e to the x times the quantity of x minus 1, and then we have just copied our denominator. Number 19, we are given h of x equals 2x to the 4th cot x all over 3x squared, and it simply gives us h prime of x equals 3x squared times the quantity of 8x cubed cot x minus 2x to the 4th CSC squared x minus 2x to the 4th cot x 6x all over 3x squared to the power of 2. We have obtained this one by applying the quotient rule. So compressing them all together, we have obtained 24x to the 5th cot x minus 6x to the 6th CSC squared x minus 12x to the 5th cot x all over 9x to the 4th. It's because 3x squared is 9x to the 4th. Now to simplify it furtherly, it gives us h prime of x equals 12x to the 5th cot x minus 6x to the 6th CSC squared x all over 9x to the 4th. And by simplifying it further, we have obtained h prime of x 4 over 3x cot x minus 2/3 x squared CSC squared x. This is simply dividing each term from the numerator by the denominator. 12 over 9, that would be 4/3, 6 over 9, that would be 2/3, and also the following terms, which are the x cot and x squared CSC squared x. For number 20, we are given the function f of x equals CSCx all over negative 4x e to the x. Now, the very thing that we need to do here is to apply the quotient rule. So that gives us negative CS CX cot x times the quantity of negative 4x EX. That this would be VDU minus UDV minus CS CX. Then the derivative of 4x negative 4x e to the x is negative 4ex times the quantity of 1 plus x all over negative 4x e to the x to the power of 2, which is our v squared. Now to compress them, we have obtained 4e to the x CS CX times the quantity of x cot x plus the quantity of 1 plus x all over 16x squared e to the 2x. And now for our final answer, by simply cancelling out the numerator from denominator in terms from the outside term of numerator and our denominator. The factor there is 4, so cancelled out 14ex, rather our factor. Therefore, the remaining terms are CSCX times the quantity of x cot x plus 1 all over 4x to the squared e to the x. Since 16 divided by 4 is 4, and then x squared is still there, and then e to 2x, e to the power of 2x divided by e to the x is ex. So that is why we have now 4x to the power of 2 e to the x as our denominator. Moving on to another set, which is from 1 to 28, starting from number 1. This is an application of the quotient rule. The chain rule rather. So we are given f of x equals 2x squared minus 5x to the third. So applying the chain rule, 3 times, which is the outer one, we are first going to not copy the inside term, because we will have it copied to our final answer. So our outer function will be 3, and then with a close and open parenthesis to the power of 2, and then we are now going to get the derivative of the inner function, which is 4x minus 5, since the derivative of 2x squared is 4x, and then the derivative of negative 5x is negative 5. Now to fully express the answer, we now obtain f prime of x equals 3 times the quantity of 2x squared minus 5x squared times 4x minus 5. That is our number 1 answer. For number 2, we are given f of x equals the square root of 5x cubed minus 2x. So let us set this into a rational form. So that would be 5x cubed minus 2x to the power of 1 half. And then applying the chain rule, it gives us 1 half, and then with the parenthesis open and close to the power of negative 1 half times the derivative of the inner function, which is 15x squared minus 2. Now applying them all together, it gives us, or putting them all together, it gives us 1 half times the quantity of 5x cubed minus 2x to the power of negative 1 half times 15x squared minus 2. And since we have there negative 1 half, we can put it below the fraction. So, and we can have 15x squared minus 2 as our numerator, since it doesn't have any negative power. So our answer there is 15x squared minus 2 all over 2 from the 1 half square root of 5x cubed minus 2x. Now for number 3, we are given y equals 3 sine x minus 3. Applying the chain rule, y prime equals 3 cos open and close parenthesis times 1, and thus we have obtained 3 cos times the quantity of x minus 3. Now moving forward to number 4, y equals negative 2 cos times the quantity of x squared plus 2. So applying the chain rule, negative 2 times negative sine open and close parenthesis, since we cannot put our inner function for now for the second process, and we are going to put it on the final na. So, and then times 2x from the derivative of the inner function x squared plus 2. So now, by putting them all together, we have obtained answer, which is y prime equals 4x sine times the quantity of x squared plus 2. Now for number 5, we are given g of x equals sine squared 3x squared. So applying the chain rule, we have obtained 2 sine open and close parentheses times cos 3x squared times 6x. So applying them all together or combining them all together, 6x times 2 sine, that will be 12x sine, and then 3x squared cos 3x squared. Since if you ever wonder why there is 2 3x squared there, it's because we have already included the outer function from the second term. So there is 3x squared there and cos 3x squared. Therefore, we have obtained 12x sine 3x squared cos 3x squared. Now for number 6, we are given the function h of x equals 6 sec cubed or times the quantity of x squared minus 5. That would be h prime of x equals 3 sec squared open and close parentheses times sec x squared minus 5 tan x squared minus 5 times 2x. So we know that the derivative of sec is sec x and tan x, and then therefore we have just included our inner function to them. And then the derivative of the inner function, x squared minus 5, is simply 2x. So now h prime of x equals 3 sec squared x squared minus 5 times 6 sec x squared minus 5 tan x squared minus 5 times 2x. So combining them all together from what we can combine, so 2x times 3, that gives us 6x, and then sec cube, it's because we see there 2 sec with the same inner function. So it became sec cube x squared minus 5, or sec cube times the quantity of x squared minus 5, and then tan x squared rather, sec cube times the quantity of x squared minus 5 tan x cubed minus 5. Therefore, our answer for this given function, which is sec cube times the quantity of x squared minus 5, is 6x sec cube times the quantity of x squared minus 5 tan x squared minus 5, or tan times the quantity of x squared minus 5. For number 7, we are given f of x equals 3x to the third e to the power of 2x minus 5. So this is simply applying the product rule, and that gives us 9x squared e to the 2x minus 5 times 3x cubed times 2e to the power of 2x minus 5, and it simply gives us 9x squared e to the power of 2x minus 5 plus 6x cubed e to the power of 2x minus 5. Now for our number 8, we are given the function g of x equals negative 5x squared ex squared plus 3x. So getting its derivative, that will be g prime of x equals negative 10x e to the power of x squared plus 3x plus negative 5x squared times e to the power of x squared plus 3x times 2x plus 3. Therefore, we have obtained, by applying the product rule, our answer would be negative 10x e to the power of x squared plus 3x minus 5x squared times the quantity of 2x plus 3 times e to the power of x squared plus 3x. Now for number 9, we are given the function y equals 3x squared times square root of 4x squared minus 5x plus 1. And we can set this into its rational since we see a radical term there, a radical symbol there. So that turns into 3x squared times the quantity of 4x squared minus 5x plus 1 to the power of 1/2. So now we can apply the product rule, and that gives us 6x times the quantity of 4x squared minus 5x plus 1 to the power of 1/2 plus 3x squared times the quantity of 1/2 times the quantity of 4x squared minus 5x plus 1 to the power of negative 1/2 times the quantity of 8x minus 5. Therefore, by combining them all together, applying operations necessary for this case, it gives us the answer, which is 6x square root of 4x squared minus 5x plus 1 plus 3x squared times the quantity of 8x minus 5 all over 2 square root of 4x squared minus 5x plus 1. And now for number 10, we are given h of t equals 2 third t to the third square root of 3t cubed minus 5t. So before we can proceed, we can set the radical condition there as 3t cubed minus 5t to the power of 1 half. Now we can proceed by applying the product rule. So h prime of t equals 2t squared times 3t cubed minus 5t to the power of 1 half plus 2 to the 2 over 3t cubed times the quantity of 1 half times the quantity of 3t cubed minus 5t to the power of negative 1 half times 9t squared minus 5. So by compressing them all together by applying necessary operation, it gives us h prime of t equals 2t squared square root of 3t cubed minus 5t plus t cubed times the quantity of 9t squared minus 5 all over 3 square root of 3t cubed minus 5t. So the very reason why we have put 3 square root of 3t cubed minus 5t below t cubed times the quantity of 9t squared minus 5, it's because its its power is in negative, so we need to put it under for it to be positive. So that is for our number 10. Moving on for our number 11. Y equals 1 all over the cube root of x cubed minus 4x squared plus 1. So we can set this as x cubed minus 4x squared plus 1 to the power of negative 1 third. So applying chain rule, we have obtained negative 1 over 3 times with a open and closed parenthesis to the power of negative 4 thirds, and then the derivative of the inner function, which is 3x squared minus 8x. So therefore, we have obtained negative 1 third, copying now the inner function, which is x cubed minus 4x squared plus 1 to the power of negative 4 thirds. By the way, it became negative 4 thirds because we have subtracted 1 from it. And then we have also multiplied our power to the leading coefficient. That is why it turns into that. And then our derivative for the inner function is 3x squared minus 8x. So we can also put this under our numerator, since we can see a negative power there. So we can put 3x squared minus 8x as our numerator, and then we can put 3 times the quantity of x cubed minus 4x squared plus 1 to the power of 4 third as our denominator. Therefore, we have obtained negative 3x squared minus 8x all over 3 times the quantity of 3x cubed times the quantity of x cubed minus 4x squared plus 1 to the power of 4 thirds rather. So that is our answer for number 11. For number 12, g of t equals negative 3 all over the fourth root of 2t cubed plus 5t minus 3. So we can also set this as negative 3 times 2t cubed plus 5t minus 3 all over negative 1 fourth. And then applying the chain rule throughout the process, it gives us 3 over 4 times 2t cubed plus 5t minus 3 to the power of negative 5 all over 4 times 6t squared plus 5. And since the power of our one quantity there is a negative, so we must put it below or set it as a fraction, so we can put it below. So we can have 3 times the quantity of 60 squared plus 5 as our numerator with respect to 3 fourth, and then we can also put 4 times the quantity of 2t cubed plus 5t minus 3 to the power of 5 fourth as our denominator. So therefore, our answer is 3 times the quantity of 60 squared plus 5 all over 4 times the quantity of 2t cubed plus 5t minus 3 to the power of 5 over 4. For number 13, we are given g of m equals sine cos m. So g prime of m equals cos, open and close parenthesis, applying the chain rule times the quantity of negative sine m. So that gives us negative sine m cos times the quantity of cos m. This is through the application of the chain rule. Now moving on. Moving on up to our number 14, f of x equals cos tan x. This is applying the chain rule, which is f prime of x equals negative sine u, which is from outer function times sec squared x times 1. So by applying them all together, we can have or obtain the answer negative sine tan x sec squared x. Number 15, h of x equals the square root of x cubed plus 2 times x squared minus 1 to the 4th. So we can set it as x cubed plus 2 to the power of 1 half times x squared minus 1 to the 4th. So therefore, we have obtained h prime of x equals 3x squared all over 2 square root of x cubed plus 2 times x squared minus 1 to the 4th plus square root of x cubed plus 2 times 8x times 8 times x squared minus 1 to the 3rd. And by simplifying it further, we have obtained 3x squared times the quantity of x squared minus 1 to the 4th all over 2 square root of x cubed plus 2 plus 8x square root of x cubed plus 2 times x squared minus 3 x squared minus 1 rather to the power of 3. Number 16, we are given h of m equals square root of m squared plus 1 times the quantity of m squared plus 1 cubed. So we can set square root of m squared plus 1 as m squared plus 1 to the power of 1 half. And so we can proceed now with our answer. So this is an application of product rule. So therefore, we have obtained m all over square root of m squared plus 1 times m squared plus 1 to the 3rd plus the square root of m squared plus 1 times 6m times the quantity of m squared plus 1 squared. So simplifying it furtherly, we have obtained h prime of m equals m times the quantity of m squared plus 1 to the 3rd all over square root of m squared plus 1 plus 6m times the quantity of m squared plus 1 squared times the square root of m squared plus 1. This is the very good thing of applying every rule of the differentiation of functions so that we will know how to differentiate them. For number 17, we are given f of t equals the third root of t squared plus 2 all over t squared minus 2. So we can also rewrite this one into t squared plus 2 all over t squared minus 2 to the power of 1/3. So applying the chain rule, we have obtained 1 over 3 times t squared plus 2 all over t squared minus 2 times negative 8t all over t squared minus 2 squared. So by obtaining the derivative of the inner function, we should apply the quotient rule before we can input it as the derivative of it. So that that is our answer, which is 1/3 times the quantity of t squared plus 2 all over t squared minus 2 times negative 8t all over t squared minus 2 squared. Moving on to number 18, which is f of t equals the fourth root of t cubed plus 8 all over t cubed minus 8. So this can be t cubed plus 8 all over t cubed minus 8 to the power of 1/4. So f prime of t equals 1 all over 4 times the quantity of the quantity of the outer function to the power of negative 3/4 times negative 48t squared all over t cubed minus 8 to the power of 2. So now by applying the chain rule together, we have obtained f prime of t equals 1 all over 4 times t cubed plus 8 all over t cubed minus 8 to the power of 3/4 times negative 48t squared all over t cubed minus 8 squared. So for number 19, h of x equals 2x plus 5 to the power of 7 times 3x to the fourth minus 8 to the power of 5. Now h prime of x equals, this is an application of the product rule. So that gives us 7 times the quantity of 2x plus 5 times 2 times 3x fourth minus 8 to the power of 5 plus 2x plus 5 to the power of 7 minus 5 times the quantity of 3x 4 minus 8 to the fourth times 12x to the third. So compressing them all together, we have obtained 14 times the quantity of 2x plus 5 to the 6 times 3x to the fourth minus 8 to the fifth plus 6x cubed times the quantity of 2x plus 5 to the power of 7 times 3x 4 minus 8 to the power of 4. Number 20, we are given g of n equals 3x squared minus 2 times 4x cubed plus 1. So this is simply applying the product rule, which gives us now 6x times the quantity of 4x cubed plus 1 plus 3x squared minus 2 times 12x squared. So now g prime of n equals 6x times 4x cubed plus 1 plus 12x cubed times 3x squared minus 2. For number 21, we are given f of t equals c as c squared times t cubed. So this is an application of chain rule, and thus it gives us the answer. F prime of t equals negative 6t squared c as c squared t cubed cot t cubed. That is for our number 21. Now for our number 22, f of t equals cot to the fourth times the quantity of 2t squared. This is also an application of chain rule. It's through getting the derivative of the outer and the inner function, and thus it gives us negative 16t cot cubed times 2t squared c as c squared 2t squared. That is our answer for number 22. For number 23, we are given h of x equals e to the power of the square root of 2x cubed minus x squared. The same thing from number 22, applying the chain rule. Therefore, we have obtained e square root of 2x cubed e to the square root of 2x cubed minus x squared times 6x squared minus 2x all over 2 square root of 2x cubed minus x squared. Now for number 24, f of x equals e to the square root of 4x squared minus 3x, and applying the chain rule, we have obtained e to the square root of 4x squared minus 3x times 8x minus 3 all over 2 square root of 4x squared minus 3x. This is simply getting the outer and the inner derivative of the given function. Now for our number 25, this is kind of complex. H of x equals 3x all over 3 square root of 5 plus 2x squared, or we can rewrite this as 3x times the quantity of 5 plus 2x squared to the power of negative 1/3. Now to proceed, we are going to apply the product rule, which now becomes 3 times the quantity of 5 plus 2x squared to the power of negative 1/3 plus 3x times negative 4x all over 3 times the quantity of 5 plus 2x squared to the power of negative 4/3. Now, by compressing them all together by applying the necessary operations, we have obtained h prime of x equals 3 times the quantity of 5 plus 2x squared to the power of negative 1/3 minus 4x squared times 5 plus 2x squared to the power of negative 4/3. Now h prime of x equals 5 plus 2x squared minus 4 over 3 times 3 times the quantity of 5 plus 2x squared minus 4x squared. This is getting the factor of it, which is 5 plus 2x to the 2 minus 4, which is 5 plus 2x squared to the power of negative 4/3. Now, we are going to factor 3 times the quantity of 5 plus 2x to the 2 to the power of negative 1/3, and it gives us 3 times the quantity of 5 plus 2x squared, and then factored out the second term, that gives us negative 4x squared. So therefore, we have obtained 5 plus 2x squared minus the power of negative 4, 3 times 15 plus 2x squared. So since we see a negative power there, so we can set the answer as a fraction, and then so we can put the the first term as its denominator. So our answer would be 15 plus 2x squared all over 5 plus 2x squared to the power of 4 over 3. Okay. Number 20.